Okay. In order to do implicit differentiation, the first thing is to understand what do they mean by that. So there is two ways of doing differentiation. One is called explicit, one is implicit. So implicit just means that we are not doing it directly. So for example, if you have 2y equals to 3x, we'll do y equals 3 over 2x. Then we do dy dx, and that give us 3 over 2. So this is called explicit. So we have a y as a function of x. Then we do derivative right on the function. Now, implicit, we'll do the same thing on this one. What do we mean by that? Is we actually going to take derivative on both sides of the equation. So we're doing like that and that. And we take the differentiation with regard to x. So basically, we are doing using a chain rule here. The chain rule is y equal to 2y, and dy du. So this thing kind of like another function, u. So we can like u equal to 3x, and we do du over dx is actually du over dy, then times dy over dx. Now this one is the y prime, dy dx. No, that we're going to find out what that is. So in this case, what we're going to do here, we know du over dy, that's easy, just 2. So dy over dx. So on this side, we got 2 dy over dx, and this side we know just 3. So therefore, we divide by 2 on both sides, then dy dx is 3 over 2. So we got exactly same answer. But this one just show you, actually for this kind of problem, you really don't have to do the implicit. But for some problems, and it's much better to do implicit differentiation than explicit. So for example, we have something like this, y squared. So we know this is circle, x squared plus y squared equal to r squared. That's the equation for a circle. So y squared is equal to r squared minus x squared. And we know we'll have basically 2 functions out of that. Is r squared minus x squared. So we have a circle like that. And circle is not a function. Because you will fail the vertical line test. If you put the vertical line here, we actually have 2 intersection points. So this is not a function. So, but here we actually make that into 2 functions. One is on the top, and another one is the negative part on the bottom. So we actually make that into 2 functions. And then we take derivative on both sides. No, take derivative on the function itself, and that give us dy over dx. This side is easy, but that side is actually think a new function, a half, which is square, and u is r squared minus x squared. Now du dx, that's easy, it's negative 2x. So on this one, if we take derivative, we take actual derivative on the whole thing here. So the first one, we take derivative with respect to u, which is half, and of course plus minus, and u negative half. Then we have negative 2x, and that give us 2 and 2 cancel, and negative and positive become negative, negative positive. We still have plus minus. So we got x over square root of u. So we got dy over dx is given to plus minus x and r squared minus x. Now we can still do this one, but if we use implicit differentiation, that becomes way easier. So let's try this. Now we take derivative on both sides, and remember this is with respect to x. Okay. So now first one, we know this is x squared prime plus y squared prime, and this is a constant, so 0. And on this side, we got 2x. On this side, we got 2y. But remember, there is also dy dx, so it's y primed. So think this is that du over dx, not dy, du is du over dy, then times dy over dx. Now, d over dy, of course, is 2y. So I have that. So that's what we got here. Now equal to 0. So therefore, what we have, y prime is, we got 2y here. The other side is 2x. And then y prime is simply negative 2x over 2y. So which is negative x over y. So what is y then? We know y is, based on this, we already know y is plus minus square root r squared minus x squared. So therefore, we got exactly the same answer, plus minus of that. But this way is a lot easier. Okay, so with that, we're going to do the problem. And remember, when we're doing this, we actually have to use a chain rule, which is basically this one. If you think what u is y squared, then we have to go through that. So du dx is actually du dy times dy and dx. Okay, so with that, then we can do solve some problems. Okay, I'm going to go to this one here. Okay, so let's go. Now we have that. Remember, when we do that, we actually take derivative on both sides. So what we do is we do 2xy plus x3 minus 3y squared, and take derivative on this side, and this is take derivative, and of course this is a constant, 0. And here we go have 2xy prime and x3 prime minus 3y squared prime. And this is 2xy prime because the constant can move out, and this is that. That's the easy one. And here, remember, we can move 3 out, then we just have that, and this is 0. And so always have these equations when do implicit. Now this one, we have to use the product rule first. Take derivative on x, we got y. Then take derivative on y, we got y prime. And 3x squared. And this one, then we have a change rule. So this is going to be 2y and times y prime equal to 0. Now we just combine the like terms. So we got 2y plus 2xy prime. So we have that. Then plus 3x, the minus 3 times 2, 6y, y prime equal to 0. Then put the y prime together. So y prime is 2x minus 6y. And then everything else move to the right. So we have to move this one and that one to the right. So that becomes negative 3x squared minus 2y. So therefore, y prime is equal to negative 3x squared minus 2y. Bottom is 2x minus 6y. So what do we have? And if you notice, 2x minus 6y, we only have this one. That's the only one we have. And if we move negative 1 out, of course, what we have is then 2y plus 3x squared over 2x minus 6y. So we know this is the correct one. Take that. Okay, let's do the second one. Oh, let's do the first one. We got right. Second one, we have to take a differential first, then we plug in a number. So we know the point we have is x equal to 1, y equal to 2. So same thing, we're going to do this on both sides. Three, take a derivative here. So x squared derivative minus 3xy derivative plus y third derivative, and this is 0. So this gave us 2x, and this one is product rule. So we got y plus x y prime, and this one just 3y squared y prime equal to 0. Now in this case, because we have the value already, we don't have to find the equation. So we just plug the number in. So 2 times 1 is 2, and here y is 2, and x is 1, so y prime. And 3y squared then give us 4 y prime equal to 0. So combine it, 2 minus 2 times that is 6 minus 3y prime plus 12 y prime equal to 0. Now 2 minus 6 is -4, and this one is -3 y prime plus 12 1 prime, that's 9 1 prime equal to 0. Then we got 9 y prime equal to 4. Then y prime is 4 over 9. So we know this is the last one. I have that. Okay, I go to the next one. Now this we have to work it out. But the same thing, we're going to do the derivative on both sides. And 3 prime, that's 0. That's the easy one. And here we have 2x to the third prime minus 5xy prime. So all the constant coefficient, we can move it out. Then minus y squared prime. So this one, that is 2 times 3x to the second power. This one we have y plus x y prime, and this one is negative 2y and y prime equal to 0. So we got 6x squared minus 5y minus 5x y prime minus 2y y prime equal to 0. And we combine that, the y prime. So y prime is negative 5x minus 2y. On the other hand, that we can move to on the right-hand side equation, become 5y minus 6x squared. So y prime then is 5y minus 6x squared, negative 5x, negative 2y, and we know we can make that into positive, so we got 6x squared minus 5y, bottom is 5y plus 2, sorry, 5x plus 2y. So what we have, 5x plus 2y actually is the only one here. And we know the top is 6x squared plus negative 5y. So we got this, got that. Now we are going to do the next one, next problem. So we have that, we got same thing. We go x squared, no, x third y plus y squared minus x squared equal to 5. Take the derivative, both sides. And now we have x to the third y prime plus y to the second prime minus x to the second power prime. And this is 0. And that we use the product rule. So we got 3xy that, then x to the third y prime. And this one just 2y and y prime. And this one is 2x equal to 0. Now we can just plug in a number. So x is 2. So we got 3, 2 squared, and y is 1. So that's 1. And plus 2 to the third y prime plus 2y, y is 1, so it's 2 y prime minus x is 2, so it's 4 equal to 0. So we got 2 squared is 4, 4 times 3 is 12. Then this is 8. And this 2y prime minus 4 equal to 0. And so we got 10y prime plus 8 equal to 0. So y prime then is negative 8 over 10. Then that's negative 4 over 5. So that'd be our first one. Our first one. Okay. All right. So I hope that this works. Help you to understand how to do this. Okay. I'll see you next time. Bye.